Hello, ladies and gentlemen. We're going to do 6.4. We're going to be finding the inverse of a function. Our objectives are to find the inverse algebraically, graphically, and by reversing points. And then we're going to talk again about the vertical line test and then get a new test called the horizontal line test. All right, so let's start off by defining what an inverse relation is. And if you'll remember, a relation is a set of points that create some type of image. Okay, so there's our inverse relation. The definition is that it interchanges, brain and mouth aren't working at the same speed. The input, which is x, and the output, which is y. Okay? So it's going to interchange those two values. All right, so for example, let's say I'm given a relation and it's going to have points x and y. Okay? So I'm going to have 0, 1, 2, 3, and 4. And then my y values are going to be 6, 4, 2, 0, and a negative 2. So I could plot those points and come up with what the graph looks like. So if I want to do the inverse of this particular relation, I'm going to flip-flop my x and y's. So now I'm going to have 6, 4, 2, 0, negative 2, and 0, 1, 2, 3, 4. Noticing that the y's became x's and the x's became y's. So that would be the inverse of this particular function. The way that I write an inverse is f raised to the negative 1 of x. And so that tells me that I'm talking about an inverse. So let's see what happens if I graph these two sets of points. Okay. So in my first one, I have 0, 1, 2, 3, 4, and my y's go up to 6. 1, 2, 3, 4, 5, 6. Okay, and there's a 4. There's a 0. So I have a point 0, 6. I have the point 1, 4. And then I have the point 2, and there's a 2. There's that point. And then I have the point 3, 0. There's my x-intercept, and 4, negative 2. So down there. If I connect all those points kind of nicely, it almost looks like a line. Okay? And so that would be the original relation. So now what I'm going to do in a different color is plot the inverse points. So now I have 5, 6, 6, 0, 4, 1, 2, 2, it goes through the same point, 0, 3, and then a negative 2, and then 4. So about here. So then if I collect these points, they go this way. So this is my original relation. This would be the inverse. Okay? So that's kind of cool. And then I'll tell you more information later. But actually what happens is it is a reflection of the original line across the line y is equal to x. Okay, and so we'll talk a little bit more about that later, and we won't actually do many of these problems graphically, but we will talk about how to do them later. All right, so there's three ways or three methods to find the inverse. And remember, I write it as f to the negative 1 of x of a relation. Okay? All right, so here are going to be my three steps. Okay, scoop my paper up just a bit. The first one we would do just what we did up here. I'm going to flip-flop, very technical word. I'm going to flip-flop the x and y coordinates. And then I would regraph, okay? And then I would be able to have my original functions. The second method is to, I was going to write method, reflect across the line y is equal to x. Okay, so I would take my original image, and I'll kind of show you an example of this. So let's say I had a parabola. Okay, and so here would be my parabola, and I want to reflect, oops, you can't see the whole thing, I'm going to reflect that parabola across the line y is equal to x. Okay, so there's this line, that's y is equal to x. So to be able to pull off the point, so let's say this point reflects across, it's on the line of reflection, so it stays. Then I'm going to have, oh, this hurts my head. Oh, can I do it? I think I can. That point, we'll take that one right there, is going to reflect across, it would be right here. Okay, this point that's kind of underneath is going to be here. Okay, this point that's up above would come down here, and then really a hideous graph. My graph, oh, so sorry, so bad, is going to look like this. Okay, and when we actually get to where we're doing reflections across the line of y is equal to x, we'll do it on graph paper and make it look better. All right, then our third method is by using algebra. And this is the method that we're going to use primarily right now. Later we'll do more with graphing, and it's actually kind of fun. But I'm going to flip-flop the x and the y in my equation. The key thing is I'm going to solve for y. This is a step that most people forget to do. So I'm going to flip-flop my x and my y, and then I'm going to solve for y. And before we actually start doing any examples, I'm just going to give you a little bit more information. One of the types of problems that you will have to do is a verification, and it would say verify that two functions are inverses of each other So if I have f of g of x and I get an x, so I do the composition of f of g of x and I get an x, and then if I do the composition the other direction, g of f of x, and I also get x, then that tells me that f of x and g of x are inverses. So this is a way of proving that two functions are inverses of each other just by doing a composition, which is why we learned how to do the compositions first. All right. So we're going to do an example of that actually first. So I want to verify that f of x is equal to 3x minus 5 and g of x is equal to 1/3 x plus 5/3 are inverses. And if I want to do that verification, I do that verification by doing the compositions. So I'm going to check both compositions. I'm going to check f of g of x, and then I'm also going to check g of f of x. So before we get started, I'm actually going to rewrite this because I think in a different format it's a little bit easier to use. So I'll show you how I do it. This is x over 3 plus 5 over 3, and that's going to turn out to be x plus 5 over 3. So if it's written as one fraction, it actually makes the math a little bit less busy when we're trying to work through our compositions. All right, so let's do f of g of x first. So that means that my g of x is going to be x plus 5 over 3. Now I'm going to substitute that back into my f of x, so I'm going to have 3 times x plus 5 over 3 and then minus 5. Well, notice that the 3's cancel, and I'm left with x plus 5 minus 5. The 5's cancel, and I'm left with x. So that's very nice. So f of g of x gave me x. So now I'm going to do g of f of x. Okay, so I'm going to start with f of x, which was the 3x minus 5, and I'm going to substitute it into g, so I'm going to have 3x minus 5 plus 5 all over 3. And remember, this piece right here is the x that I substituted into that equation. Okay, if I simplify the math, I get 3x, the 2 5's cancel over 3, the 3's cancel, and I'm left with x. So both of the compositions yielded an x, therefore I know that f of x and g of x are inverses of each other. So they are indeed inverses. Okay. Alrighty, so that was very nice. Alright, so now I'm just going to do another couple of examples. Okay, so in the next example says find the inverse And then it says to verify the inverses, which means that we need to do that with a composition. So you're going to be given that f of x is equal to x plus 4. So the first thing that I want to do is find the inverse of that particular function. Okay? So here's my notation, f to the negative 1 of x, and then I'm going to do my work. So I'm going to do this algebraically, and I'm going to flip-flop my x and my y. This is the y, this is the x. So now I'm going to say x is equal to y plus 4. So by flip-flop, I mean that they both traded places on sides of the equation. The next step is to actually solve for y, and that's the piece that most people forget. So I'm going to subtract 4 from both sides, and I'm going to get y is equal to x minus 4. So my inverse, f to the negative 1 of x, is actually going to be x minus 4. Okay? Alrighty, that was actually pretty easy. Okay, so there's my inverse. So now I'm going to do the verification process. So I'm going to do f of the inverse of x. Okay, so I'm going to do that one first. So there's the f. My input is going to be x minus 4, and I'm going to put that into my original function. So I'm going to have x minus 4 plus 4. The 4's cancel, and I'm left with x. So that was very polite. Now I'm going to verify it going the other direction. So I'm going to do f of, sorry, there's my parentheses, f of x. Okay, so I'm going to do the inverse of f of x. So here's my inverse. My f of x was x plus 4. Substituted into the inverse equation, and I get x plus 4 minus 4. Again, those cancel, and I'm left with x. So I verified my math. Alrighty. So now I'm going to do another example, and I'm going to find the inverse algebraically, and then I will show you what it looks like in your grapher. So I'm going to find the inverse, and then I'm going to graph both on the same axis. All right, so the equation that I want to find the inverse of is f of x is equal to x squared, okay? And I'm only going to look at, actually I'll just do that one, okay? So now if I find the inverse, I'm going to flip-flop my x and y, so I'm going to do x is equal to y squared, and I'm going to solve for y. So I'm going to get y is equal to, by taking the square root of both sides, plus or minus the square root of x. Okay, oops, I guess you can't see that, so sorry. Okay, so now I get y is equal to plus or minus the square root of x. So my inverse is equal to plus or minus the square root of x. All right, so let me get my handy-dandy calculator. Okay, put that up there. I think you can see it. And so I'm going to go to my y equals, and I'm going to clear all the gobbledygook that was there. And I'm going to enter x squared for my first one. And remember that this is a parabola. So there's my handy-dandy parabola. We know what that looks like. So now I'm going to go back to my y equals, and I'm going to enter my inverse. The problem with entering the inverse is I have to do the plus and minus on two separate lines. So the first line I'm going to do the positive square root of x, and then on the second line I'm going to do the negative square root of x, close, and I'm going to graph. Okay, so there's my parabola, and there is the square root function. And if you could imagine that there's the line y is equal to x is going right through there, this graph was flipped over that line, and now I have the reflection of the parabola. So that's what it would look like if I put both graphs on the same graph. So it's actually kind of cool. Alrighty, so the next thing that I want to introduce or talk about is the vertical line test and a new one called the horizontal line test. Okay, so let's go back and talk about the vertical line test. So let's say I have a relation, and this happens to be my relation. The purpose of the vertical line test is to decide whether it's a function. So if I run a vertical line through my function, and I only have one point of intersection, then we know that that is a function. So we would say that f of x is equal to a function, okay, because it only passed, or sorry, the vertical line only had one point of intersection. Well, the horizontal line test is kind of cool, and the horizontal line test talks about the inverse. So I'm going to get a different color. Maybe it'll be helpful. So now I'm going to run a horizontal line. Woo, look at that. Run a horizontal line through my function. But notice when I run the horizontal line through, I have 2 points of intersection. So the horizontal line test tells me about the inverse. Okay, so it's going to tell me if the inverse is a function. So in this case, because I had 2 points of intersection, I know that the inverse is not a function. And I'll verify that by kind of redoing the graph that we just did. So if I take this function, here's, oops, I missed, there's our little function, and I reflect it, this becomes the inverse. Okay, so this would be f of x, and this would be f to the negative 1 of x, okay? Notice that when I run a vertical line through my inverse, that it does not pass, because it has 2 points of intersection. So the horizontal line test is done on the original function, and it tells me whether or not the inverse is going to actually be a function. All right, so that's what we use our vertical line test for. All right, so now let's go and find the inverse of something that has a higher power, okay? So let's find the inverse. And I want to find the inverse of f of x is equal to x to the 6, all right? So I'm going to do this algebraically. So my inverse, here are the steps. I'm going to flip-flop my x and my y. And now I need to solve for y. Well, if y is raised to the 6th power, the way that I undo that is taking the 6th root of both sides. And notice that the 6 is even, so my y is going to equal plus or minus the 6th root of x. And you could have written it as x to the 1/6, that would have been okay. So I would finish the problem by saying that my inverse is going to equal plus or minus the 6th root of x, and then that would be my lovely little answer. Okay? Alrighty, so now let me do one more problem for you, and then we'll get on to your problems for the evening. Alright, let me scoot my little paper over. Here's your last example. Okay, again I'm going to find the inverse. Okay, so I'm going to find the inverse. This time I'm going to have g of x is equal to 1 over 27x cubed. So the first step is to always flip-flop your x and your y. So we're going to say x is equal to 1 over 27 y to the 3rd. So I need to solve for y. So the first thing that I'm going to do is I'm going to multiply this side of the equation by 27, and I'm going to multiply this side of the equation by 27. So now the 27's on this side cancel, so I get y to the 3rd is equal to 27x. Well, to undo a power, I raise it to the root. So I'm going to take the 3rd root of both sides, and I'm going to get y is equal to the 3rd root of 27 is 3, and then there's my x to the 1/3. So I would finish by using my good notation that says 3x to the 1/3, that's an equal sign, and then ta-da, done. Alrighty, so let me give you your problems, okay? Alrighty, the first two say find an equation for the inverse. Number 1, y is equal to a negative 2x plus 5. And number 2, y is equal to a negative 2/3 x plus 2. The next set says verify that f and g are inverses by showing that the compositions equal x, so that f of g of x is equal to x, and that g of f of x is also equal to x, okay? So problem number 3, f of x is going to equal 2x plus 3, and g of x is going to equal 1/2 x minus 3/2. And I'm going to rewrite that for you because it's so much easier to do like that, okay? See if I can get us focused a wee bit. All right, then number 4, f of x is going to equal 1/5 x minus 1, and g of x is going to equal 5x plus 5. Then I have two more problems for you. I want you to find the inverse of the power function, and it's called a power function because the variable is raised to a power. So 5 f of x is going to equal a -1/64 x to the third. And then your last problem, number 6, oops, sorry, I lied, I have to give you g of x. No, that's number 6, my bad, brain and mouth aren't working. G of x is going to equal 16/25x squared. Alrighty, there are your 6 problems for the evening. Good luck, and I will see you tomorrow.